So we continue our series on non-metals. So we've looked at non-metals like chlorine and nitrogen and its compounds. So today we're going to continue on to sulfur. So sulfur is another non-metal. It's basically found as pyrites. That's in its ore form. That's iron sulfides. So this is the ore form, the raw form in which sulfur is found, or as gypsum. That's calcium tetrasulfate. Tetrasulfate 6, and of course it's hydrated. So these are the forms in which sulfur is found. Now sulfur has allotropes. Allotropes of pure sulfur include rhombic sulfur, monoclinic sulfur. Alright, so we said sulfur exists in different forms, okay, of the same element, okay? So different forms of the same element are known as allotropes. They're the same elements, but they have, because the atoms are arranged or bonded in different ways due to temperature and pressure. So it could these different forms of the same element sulfur include rhombic sulfur, which is usually crystalline. Okay, it has this crystal structure. Then we have monoclinic sulfur, we have plastic sulfur, and we have amorphous sulfur. The most common allotrope of sulfur is the rhombic sulfur, and it's always symbolized by this alpha symbol, and it exists as octahedral crystals. Less common is the monoclinic sulfur, symbolized as this beta symbol, right? All right, so sulfur occurs in rings. Okay, so sulfur occurs in 8 octahedral rings. Okay, so 8 rings, 8 atom rings. Okay, 8 atom connected rings. Okay, all right. So let's look at the extraction of sulfur. The extraction of sulfur is known as the Frasch process. The extraction of sulfur is known as it's called the Frasch process. Okay, so in this process, three concentric rings are passed on the ground to the sulfur. Okay, now superheated water at about 170 degrees centigrade and 10 atmosphere pressure is passed through the outer pipe to melt the sulfur. So it looks something like these three concentric rings. Okay, all right. So superheated water at a very high temperature and pressure is passed first in to melt the sulfur, okay, which is on the ground. Okay, all right. So that's it's there here, the first ring or pipe going. So basically in the extraction of sulfur, we are using three concentric rings. So we have the one that passes the first ring, okay, shaded here, shaded and labeled A. So we're passing hot water at 170 degrees centigrade and 10 atmospheres. That's a lot of temperature and pressure. So it's to melt the underground sulfur. Then the next thing is to pass the air, hot air, through the center pipe. Hot air goes into the innermost pipe. Now hot air will push. The hot air is passed at this high pressure of 16 atmospheres through the innermost pipe, and it forces the molten sulfur, because the sulfur has been melted from the water from the first pipe, and forces the hot air now forces this melted sulfur up through the center pipe. Now sulfur of about 99.5% purity is collected in reservoir tanks. So that's the Frasch process. Alright, so let's look at the properties of sulfur. Properties of sulfur involve combustion properties. That means it burns in air, okay, in excess air to release the sulfur dioxide gas, or depending on the number of moles in the reaction, could be the sulfur 6 oxide, okay, sulfur 6 oxide. Now it also reacts with metals such as iron, zinc, and copper and lead to form sulfides. Okay, you just remember the raw form of sulfur was pyrites, okay, iron pyrites, okay, iron sulfide. So that's the form in which we find some of the raw form of sulfur. Now it also form sulfides, which tend to be black colors. Okay, of course these are our iron pyrites, or it could be copper sulfide. All right, they tend to be black in color. Now reaction with it reacts with non-metal. Sulfur combines with coke in a furnace. Coke is carbon basically. So basically, so we said that Sulfur also reacts with non-metals, not just metals, to combine with coke in a furnace. So sulfur combines with coke in a furnace to form poisonous colorless liquid, carbon 4 sulfide. Remember, coke is a form of carbon. All right, so this is a chemical reaction for that carbon 4 sulfide, which is poisonous. Sulfur also reacts with concentration oxidizing acids like triazonitrate 5 and tetrasulfate 6. All right, so that's the reaction of the acids with sulfur. All right, so that's what we have there. All right, so HCl has no action on sulfur. Take note, HCl has no action on sulfur. So uses of sulfur include as a fungicide. All right. So we're talking the uses of sulfur. Use of sulfur include as a fungicide. Okay, in the contact process. Contact process is the name for how sulfuric acid is prepared. Okay, we'll look at contact process shortly. Sulfur also has its use as vulcanization or hardening of rubber. Okay, to vulcanize rubber is to harden it. Okay, so sulfur is used in that process. Then as a bleaching agent in the paper industry. Okay, sulfur is also used in fireworks, dyes, and other sulfur compounds. Okay, so these are the uses of sulfur. So next up, we're looking at the preparation of sulfuric acid. This is contact process. So let's study the preparation of sulfuric acid using the contact process. All right, so the contact process basically occurs in 4 stages. So the first stage is the preparation of sulfur 4 oxide from its ore. All right, so sulfur is reacted with oxygen. Okay, there's a form of combustion to give you sulfur 4 oxide. All right, or it could be as a pyrite form. All right, that's an iron sulfide with in a combustion to give you sulfur 4 oxide. So this is the first stage of the contact process. We are getting a sulfur 4 oxide from its ore. Okay, from the ore of sulfur. All right, so from sulfur we get sulfur 4 oxide. So this is the first stage of the contact process. The next stage is the purification of the sulfur 4 oxide. All right, the next stage of the preparation of sulfuric acid is the purification of the sulfur 4 oxide gotten from the first stage. All right, so we have a mixture of sulfur 4 oxide and excess air. So the mixture of this and excess air are purified to remove dust particles which may poison the catalyst. Okay, so they are purified. Okay, the third stage now is the conversion of the sulfur 4 oxide into sulfur 6 oxide. All right, that's SO3 in a catalytic chamber. So in a catalytic chamber, we have this process going on, where the conversion of sulfur oxide is to sulfur 6 oxide is carried out with vanadium catalyst at this 3 atmospheres and a high temperature. It's an exothermic reaction. All right. So the third stage of the contact process, that is the manufacture of sulfurs, tetrasulfate 6 acid, commonly known as sulfuric acid. Takes place in the catalytic chamber where the sulfur 4 oxide is converted into the sulfur 6 oxide. It's by reaction with oxygen in the presence of vanadium catalyst at about 2 atmosphere pressure and 500 degrees centigrade. That's a lot of temperature, and it's an exothermic reaction. Releases about 94 kilojoules per mole. And the fourth stage and final stage is the conversion of sulfur 6 into the sulfuric acid. All right. Okay, so this fourth stage is the conversion of sulfur 4 oxide into the tetrasulfate 6, which is our target product. So the tetrasulfate 6, a limited quantity of it is reacted with the sulfur 6 oxide. It gives us oleum. All right, so it gives us oleum. Okay, now this oleum reacts with water in a dilution chamber to give us our tetrasulfate 6 of 98% concentration. So that's the final stage, conversion of sulfur 6 oxide into tetrasulfate 6. So just to recap, we have the 4 stages in the contact process. So that's the 4 stages of the contact process. First of all, we get the raw sulfur, convert the raw sulfur into sulfur 4 oxide. All right, then the sulfur 4 oxide is purified to remove dust particles, okay, which may poison the catalyst in the third stage. The catalyst in the third stage is vanadium catalyst, and it's used to speed up the rate of reaction of the conversion of sulfur 4 into sulfur 6. Now take note, sulfur 6 is not dissolved directly in water to get sulfur 6, because if you do that, it will if it's dissolved directly in water, the heat evolved will cause the solution to boil and to produce a mist of acid droplets, and you don't want that acid droplets all over your floor. All right. So let's so this is a chart showing us the contact process from sulfur to sulfur 4 oxide. Sulfur 4 oxide and excess air gives us sulfur 6 oxide. Okay, of course, with vanadium catalyst and high temperature. All right, and then sulfur 6 oxide reacts with concentrated sulfur 6 to produce oleum. So oleum is an intermediate product, and then when this is dissolved, diluted water, it produces our target sulfur 6 acid, which is in 98% concentration. Okay, so that is the contact process in the diagram. The properties of sulfuric acid, concentrated sulfuric acid, is a strong dehydrating property. It has the ability to remove elements of water, hydrogen, and oxygen from a compound. So of course, concentrated sulfur 6 is well known to be a dehydrating agent. Okay, all right. All right, so let's continue our properties of tetraoxosulfate 6 acid, popularly known as sulfuric acid. So in its concentrated form, it's a dehydrating property. Okay, so look at how it's using the dehydrating of sugars. All right, so this is known as charring of sugar to give you carbon and water. It also dehydrates copper tetraoxosulfate 6. Okay, removing its water of crystallization. So it turns from blue to white. All right, so ethanodioic acid is also dehydrated by concentrated tetraoxosulfate 6 to give you carbon 4 oxide and carbon 2 oxide. All right, so it's also a drying agent. Tetraoxosulfate 6 is hygroscopic because it absorbs water without going into solution itself. It's a good oxidizing agent. Okay, so you see it in the reaction with copper. All right, so it's the oxidizing agent. All right, so it has other uses. So let's look at other uses. All right, so let's look at popular use of sulfuric acid. It's mainly used for the manufacture of fertilizers. All right, and synthetic fibers. Okay, manufacture of synthetic fibers is used in the refining of petroleum. All right, pigments of paints is used in the pigments of paints. It's used in car batteries, of course, your acid accumulator batteries and accumulators. Okay, it's a drying agent, as we've seen. We say that tetraoxosulfate 6 is hygroscopic. Those are substances which absorb water without themselves going into solution, and it's also used in preparing other chemicals like hydrochloric acid and trioxonitrate 5 acid. Okay, so stop here, and next class we'll look at sulfur 4 oxide, which is an oxide of sulfur. Okay, all right, so basically we've looked at sulfur and its other compounds.